Example number 14. Move to example number 14. Evaluate the integral tan 2x sec 2x dx. Are we together? Hello? Just say the answer before you do it. You know the answer is what? This is a standard integral, isn't it? The answer is a half sec 2x plus, because it is a standard integral alongside algebraic substitution. Meaning when you are integrating, you divide by the derivative within a function. So remember here, when you have y to be equals to sec x, or let me say when you have y to be equals to sec t, isn't it? So it means if you differentiate y with respect to x, sec t is the same as 1 over cos t. 1 over cos t is the same as cos t raised to negative 1, isn't it? So this one is the same as cos t raised to negative 1. That is what is the same. So you differentiate the outer function, then the inner function, isn't it? This is dy over dt. So outer function is negative 1 times 1 is negative 1, then cos t raised to negative 2. You reduce the power by 1, isn't it? Then you differentiate the inner function cos t. If you differentiate cos t, you get negative sin t. So what do you get? Negative into negative is positive. So sin t over cos squared t. Sin t over cos squared t. Cos squared t is cos t times cos t. Sin t over cos t is tan t. 1 over cos t is sec t. So it means when you differentiate sec t, you get tan t sec t. So what have you seen here? What have you seen from what I've done here? You've seen that. This is just an explanation. You've seen that when you have, look here, you see that when you have y is equals to sec t, then it means dy over dt we found is sec t tan t. So if you take dt the other side, you get sec t tan t. So if you introduce integral on both sides, so if you integrate dy, you remain with y, isn't it? But what is y? Y is sec t. So using a standard integral, meaning if you are integrating sec t tan t, you will always get the answer to be sec t. Standard integral. Are we together? So if you integrate tan sec or sec tan, you get sec. So sec t. So your 2x is t. So tan t sec t. You get the answer to be sec t. Then you put back the value of t, which is 2x. Then remember at the end of integration, you must divide by the derivative of the inner function, isn't it? And the inner function, the derivative of the inner function was 2. 2x, if you differentiate, you get 2, isn't it? So you divide by 2, that's why we have a half. So standard integrals are not supposed to be done. They're supposed to be written the way I did that, okay?
Yes.
Go. Move to example number 14. That is example number. This was example 14. Example number 14. Example number 14 is what we had, tan 2x sec 2x dx, isn't it? And we found it to be, if you differentiate this, you get sec 2x over 2 plus c. Derivative of the inner function. This is a standard integral, isn't it? Tan t. So if you let 2x to be t, it means you have tan t sec t. So tan t sec t, if you integrate, you get sec t. You put your value of t, then you divide by the derivative of the inner function. Are we together? So that was the example number 14.